Alright, so let's start out by actually having you pause the video and study these properties of exponents to make sure that you know them. This is the properties and exponents that you learned in Algebra 1 and Algebra 2, and we need these indirectly. I would also pause the video and take a look at converting a rational exponent into radical form. This is just showing you the two different ways. You can see this exponent m could be underneath the radical or on the outside. It's linked to those properties of exponents on the previous page. When you have a power raised to a power, you multiply the exponents. On your test, you'll be given these properties of logarithms, so you won't have to memorize these. You have the product rule, the quotient rule, the power rule, the change of base. The change of base is primarily used to help with the calculator. If you only have a common log button and a natural log button on the calculator, but you may be working with some logarithm of a base that's different than 10 or different than e, and so if you had a log base 3, this allows you to convert it and use the calculator to get a decimal approximation for your logarithm. Here in the beginning, it's just asking us to convert this exponential equation to a log equation. So it is memorization. To identify these parts of the equation, the base is 64, the exponent is 2/3, the argument is 16. If we have log base 64 of this argument 16 is equal to 2/3, and that's all you need to do. Alright. On this next one, log base 9 of 1/3 is equal to negative 1/2. You're going the other direction. They're giving you a log equation and asking you to write an exponential form. The base is 9. A logarithm equals an exponent. A negative exponent will never make your answer negative. 9 raised to the negative 1/2 power is 1/3. Here they're asking us to rewrite it as an exponential equation, but then also to determine the value of x. So here we have a base of 25 being raised to the 3/2 power is equal to x. The 3/2 power, the denominator is the index, so this is the same as saying to take the square root of 25, and then I have the option of putting the 325 cubed or taking the square root of 25 and then cubing it. It'll be easier for me to do that arithmetic if I take the square root first. The square root of 25 is 5, and 5 to the 3rd power is 125. So here the same directions. We're taking this log equation, we're going to write it as an exponential equation and then determine the value of x. We have a base of 3, the exponent is x, that's equal to 3. Logarithms and exponential functions are one-to-one functions. One-to-one functions have this property that allows us to solve for this by saying if these two numbers are the same and the base is the same, the exponents must be the same. Here we have x raised to the 3rd power is equal to 216, and let's try to rewrite 216. I believe that 6 to the 3rd power is 216. So again, it's a one-to-one function. If these two numbers are the same and the exponents are the same, the bases must be the same. Now these are just calculator exercises, so I just cut and pasted and showed you the solution here. You're taking the log of the argument divided by the log of the base, and you could of course use natural log of 6 divided by the natural log of 14 and still get the same value. Since it's asking us to round it to 3 decimals, I let the calculator do the work, and I changed the display to round off to 3 decimals for me. Here we have log base 5 of 10 is equivalent to log 10 divided by log 5. Now that log 10 is just 1, but anyway, you don't need to know that, I guess. Just get in the the calculator and write down your values. Be careful that you close the parenthesis after, say, the 6, after the 10, and here I have the parentheses around there, that 0.25. Close that parenthesis, or otherwise it thinks you're taking the log of the value divided by that. It thinks that's all inside that's a log of that single value, and you don't want that. So be careful with the parentheses. Make sure that you're getting these same decimal numbers. If you're not, then see me and I will help you use your calculator. Alright, so here we're back to checking our reference sheet to use our properties of logarithms. Sometimes we also have to just recall our basic algebraic skills. What I would do first here is to factor both numerator and denominator to see if I have any common factors that cancel, and then jump in and use the properties to simplify this. The numerator x squared plus 2x minus 3 should factor to x plus 3 times x minus 1. The difference of squares on the denominator, x squared minus 4, and you can think of 4 as 2 squared, so you have x plus 2 times x minus 2. Then we have subtraction. This numerator factors to x plus 6 times x minus 1 over x plus 2. Okay, I don't see anything that cancels yet. Now let's use our properties of logarithms that says that if you have two logarithms of the same base and you're subtracting, that you can condense this and write it as a single logarithm. This is the log of the numerator minus the log of the denominator. So it might be helpful, however, for some students to write this as the numerator, and instead of creating a complex fraction, to use your division symbol. See, this is my numerator, and I could extend this fraction bar and write this in the denominator, or I could write this division symbol. This is the numerator divided by, and this is the denominator. It may just help with organization, because if you recall that division is the same thing as multiplying by the reciprocal. Alright, so let's see if we can simplify this. I have my numerator x plus 3 times the quantity x minus 1 divided by quantity x plus 2 times quantity x minus 2. Now, if I change this division symbol to multiplication, I have to take the reciprocal. I have to flip this fraction. So then I have x plus 2 over x plus 6 times quantity x minus 1. Alright, so now, multiplication of fractions is much easier than addition and subtraction. You just multiply straight across the numerator, straight across the denominator. Let's look and see if we have any common factors that cancel. This factor of x minus 1 divided by x minus 1 is just 1. And this factor of x plus 2 divided by this factor of x plus 2, they cancel. And of course they cancel because they were factors and not terms. We have log base 6. We have a numerator of x plus 3 and a denominator of x minus 2 times x plus 6. So I would be happy with that answer. Sometimes there is an advantage to having things in factored form. You may have some people, however, that multiply that denominator, and that's fine as well. So let's do that in case somebody did that and they're wanting to check their answer. If I FOIL this, or if I could create a table, I would have x squared plus 4x minus 12, and either one of these is fine as your final answer. Alright, let's take a look at this one. We have, let's start inside the parentheses. We have a property that says that if you're adding two logarithms together of the same base, you can condense this to a single logarithm. So I have the log base 5, and then I can just multiply x and y together. I've got x times y. Now I need to deal with these coefficients before I try to, with this minus sign, I know that I'm eventually going to be able to condense this to a single logarithm, log of the numerator minus log of the denominator. But that's only true when these coefficients, when these values in front of the log is 1. So we have by the power rule that we can move the location of this 1/2 from multiplying this log up to an exponent. So we've got x times y raised to the 1/2 power. And the same thing with this 2, we can move it up as an exponent and have this quantity x plus 1 squared. Alright, so now we have 1s in front of the logarithms, and we have a property that's the quotient rule that basically says that if the log of the numerator minus the log of the denominator, because these two have the same base. So I'll create a fraction, my numerator x times y raised to the 1/2 power, my denominator x plus 1 quantity squared. And I'm taking the log of that entire fraction. Now, some people may, in that numerator, recognize that when you have something raised to the 1/2 power, that's the same as taking the square root of it. So they may write the numerator as the square root of x times y. So if you were ever taking some standardized tests that had multiple choice answers, you would have to recognize, if this was among the answers, that it would be the correct answer, that you'd have to recognize that this product x times y raised to the 1/2 power is the same thing as the square root of this product xy. Alright, so either one of these for us is fine as the final answer. Now they give us this bit of information up at the top: log base a of 3, log base a of 11, log base a of 12. They want us to find a numerical expression for this log base a of 363 times a squared, and all we have is our properties of logarithms and then substitution to do that. So what I see here is a product 363 times a squared. Eventually this exponent of 2 will come down out in front, but right now these two factors don't have the same exponent. This is 363 to the first power times a squared. If this squared had been moved to the outside of that parentheses, I'd have to deal with that 2 first. But as it is right now, I'm going to deal with this multiplication first. So I've got log base a of 363 plus log base a of a squared. And we have seen before that when you have this base and this base being the same, that this just collapses. This is just equivalent to 2. I often say this is 2 in disguise. The 363, we're going to have to play around with 3, 11, and 12 to see if we can somehow, through multiplication, division, or taking an exponent of one of these values, get 363. So if we come over and do our scratch work over here, 363 appears to be divisible by 3, and 121 is a perfect square. It's 11 times 11. So I have a 3 and 11 up here, so I know that I can break this down and I'll then be able to substitute. So let's take a look first at 363 and say that that breaks down into 3 times 11 squared. And like I say, this guy is just the number 2, so we can go ahead and simplify that now. Now this 3 has an exponent of 1 associated with it, but the 11 has an exponent of 2. So once again, we'll split up this product before we attempt to move that exponent down. Alright, up above they tell us that log base A of 3 is this 0.683. If I move the 2 out in front, give myself a little bit more room. So now our final substitution, we know what log base A of 11 is. It's this 1.490 plus 2. So let me add that up on my calculator to make sure I don't make any silly arithmetic errors. So if I've done that correctly, I have 5.663. Since these are all the 3 decimals, I'm just going to go ahead and give my final answer here to 3 decimals. Alright. Let's move on. So that it's the same direction, same idea. We want to use our properties of logarithms to expand this and then to substitute any of these values into our expression. So we have the log of a fraction here, and we know that by the quotient rule we can rewrite it as the log of the numerator minus the log of the denominator. And as before, if this base and this base are the same, that I like to say that this is just the number 3 in disguise. And the 33, I can break that up and using these values into 3 times 11. Now I do want to be careful. If I'm subtracting this and I'm going to break this into 2 parts, I'm subtracting everything that follows, so I do need parentheses here. This product changes to addition. So I have 3 minus this sum, 0.683 plus 1.490. Alright, so again, I'm just going to jump to the calculator, trying to not make any errors entering in the numbers, and also to remember my parentheses there. Alright, so if I've done this correctly, I get 0.827. Alright, again, same directions. Now, this time I've had various people ask me, well, how do you get 16 from the 3, 11, and 12? And you do have to kind of play around with it a little bit. What I noticed that I came over and said, well, I know that 16 is equivalent to 4 squared. So if I could just get 4, well, I can get 4 by 12 divided by 3. So then all of a sudden I recognize, okay, I've got it, because log base a of 4, which is 12 divided by 3 squared. Okay. By the power rule, this 2 comes down out in front, and I've got 2 times the log of this fraction. And now we can expand the single logarithm, that log of the numerator minus the log of the denominator. And now we can substitute in the given values and just do the arithmetic on a calculator to get our final answer. So they tell me log base A of 12 is this 1.544 minus this 0.683. Alright, so let's see what we get. If I've keyed that incorrectly, I get 1.722. Alright. Same directions. Now this time, you do have to recognize how to rewrite this radical as an exponent. So the square root of 11 is the same as 11 raised to the 1/2 power. And now by the power rule, this 1/2 comes down out in front. We can substitute in the value for log base A of 11, that's given. And now if we just take half of that. So again, if I've keyed that incorrectly because I didn't want to make a silly arithmetic error, so I'm using the calculator. I've got 0.745 as my final answer. So that's it. I expect that you guys will do better on this part 2 than part 1. Eventually, when we're finished with part 3, you'll want to look back at your exam scores and then consider whether you want to do a retake or not. So I will talk to you later. Bye.